Welcome back to Aarambh Dev Hub. This is episode 5 of the Gupti series. Today is Integration Day. We are taking everything we built in the previous episodes and exposing it as a real HTTP API with Axum. By the end of this episode, the Gupti backend is fully functional. Create secret, reveal secret once, handle errors clearly, and run with middleware protections. This is the episode where separate pieces become a working server. Before we wire up the handlers, quick reminder. Subscribe to catch every episode in this series. Join the Discord for back-end development discussions. And support on Buy Me a Coffee if this content helps you. Links in the description. Let us integrate everything. Before writing handlers, let us restate the contract. Create endpoint accepts a secret string and optional TTL. It returns slug, full reveal URL, and expiry timestamp. Reveal endpoint accepts slug in the URL path. It returns the secret content once, with created timestamp. Error responses follow our typed Gupti error structure. Each error type maps to a specific HTTP status code. This contract first reminder helps prevent accidental drift during implementation. We know exactly what goes in and what comes out. Let us walk through the create handler step by step. The handler function takes two Axum extractors. State extractor gives us access to appetite with the store and config. Json extractor parses the request body into create secret request. Step 1 is validation. We call the validate method from validator crate on the request. If validation fails, we return a 422 error with details about what went wrong. Step 2 is TTL resolution. If the request includes TTL seconds, we use that value. Otherwise, we use the default from config. We also clamp to max TTL if someone tries to exceed it. Step 3 is slug generation. We generate a UUID v4 and take the first 8 characters. This gives us a short, unique identifier for the secret. Step 4 is encryption. We call our crypto encrypt function with the plaintext secret. This returns ciphertext, nonce, and key bytes. Step 5 is building the secret struct. We assemble all the pieces including slug, ciphertext, nonce, key bytes, created at timestamp, and expires at timestamp calculated from created at plus TTL duration. Step 6 is storage. We call store insert with the secret. It goes into dashmap immediately. Step 7 is building the response. We construct the full reveal URL by combining the base URL from config with the slug. We format expires it as ISO 8601 string. Step 8 is returning the response. We wrap create secret response in JSO and return it. Axum automatically serializes it to JSON and sets the content type header. This flow is linear and explicit. Every step maps directly to one product requirement. Easy to read, easy to debug, easy to test. Now the reveal handler. This is where the one-time magic happens. The handler takes state extractor and path extractor. Path extracts the slug from the URL. Step 1 is atomic take. We call store take with the slug. This returns option of secret. If the secret exists, we get it and it is removed from store in one atomic operation. If it does not exist, we get none. If none, we return a 404 error. The secret either never existed or was already revealed. Step 2 is expiry check. Even though we have the secret, we verify it has not expired. If expires at is before current time, we return a 410 gone error. This handles edge cases where cleanup has not run yet but TTL passed. Step 3 is decryption. We call crypto decrypt with the ciphertext, nonce, and key bytes. If decryption fails for any reason, we return a 500 error. The secret is already gone from storage, so it cannot be retried. Step 4 is zeroizing the key. After successful decryption, we call zeroize on the key bytes. This securely wipes them from memory. Step 5 is building the response. We create reveal response with the plaintext secret and create it at timestamp. Step 6 is returning the response. Wrap in JSON, Axum handles the rest. Notice the order of operations. We take from store first, before any other checks. This ensures atomicity. Even if 2 requests arrive simultaneously, only one can successfully take the secret. This handler is the behavioral heart of Gupti. Everything else supports this one-time reveal flow. Now let us assemble the router. We create a router with 3 routes. Post to lavdev pbhv secrets goes to the create handler. Get to lavdev pbhv secrets, Slug goes to the reveal handler. Get to lavdev returns a simple JSON with status OK. The health endpoint seems trivial but is valuable. It gives deployment systems something to ping for readiness checks. It lets you verify the server is running without side effects. We chain with state to pass apt to all handlers. This is how Axum shares data across the request handling pipeline. Route naming follows RESTful conventions. The API prefix keeps API routes organized. The slug syntax tells Axum to extract that path segment as a parameter. Now the middleware layers. This is where we add cross-cutting concerns. First, TraceLayer from Tower HTTP. This logs every request with method, path, status, and duration. Essential for debugging and monitoring. Second, CorsLayer. We configure this to allow requests from the front-end origin. Without cores, browsers block cross-origin requests. We use permissive settings for development. Third, RequestBodyLimit layer. We set a maximum body size of 10 kilobytes. This prevents someone from sending a gigabyte payload and overwhelming the server. Layer order matters in some cases. Tracing should be outer so it captures the full request lifecycle. Cores should be processed early so pre-flight requests work correctly. Body limit should trigger before we try to parse large payloads. Axum and Tower make this composable. You chain layer calls on the router, and they wrap in order. For rate limiting, we could add another layer here. Gupti includes a simple per IP rate limiter using dashmap to track request counts. But that is optional complexity we can add later. Final piece is server startup in main.rs. First, we load environment variables from main.rf file using debov. We call debov at the very beginning of main. This loads any variables from a main.rf file in the project root. The call is wrapped to ignore errors since the main.rf file is optional. Second, we initialize the tracing subscriber with environment filter. This lets you control log levels via Rust log environment variable. Third, we create apostolic from defaults. Environment variables loaded by debov or set directly in the shell can override specific values. Fourth, we create dashmap store and wrap in arc. Then we create apstout holding the store and config. Fifth, we spawn the TTL cleanup task. This background task runs forever, cleaning up expired secrets periodically. Sixth, we build the router with routes and layers. Seventh, we bind a TCP listener to the configured address, typically 0.0.0.0.3000. Eighth, we log that the server is starting. Ninth, we call Axum serve with the listener and router. This is the blocking call that runs the server. The startup sequence is explicit and ordered. Each step builds on the previous one. Fourth, after wiring is complete, we verify behavior manually. Health endpoint returns success. Create request returns slug and URL. Reveal with valid slug succeeds and returns secret. Second reveal for same slug returns 404. Reveal after expiry returns 410. Validation failures return 422 with details. This manual verification mirrors exactly what users and the frontend will experience. It gives confidence before we build the UI. You can use curl or any HTTP client. The API is standard JSON over HTTP. Quick recap of this episode. We built the complete Axum backend with create handler for storing encrypted secrets, reveal handler with atomic one-time retrieval, router with clean root definitions, middleware stack for tracing, course, and body limits, and server startup with all pieces wired together. The backend is now fully functional. You could deploy it and use it with curl right now. Next episode, we switch to the frontend. Leptos for building the UI in Rust, compiled to WebAssembly. The backend is complete and working. If you are excited to see the frontend come alive, subscribe now. Join our Discord to share your Axum experiences. And support on Buy Me a Coffee to keep this series going. All links in the description. Frontend time next. See you in episode 6.